We are just going to start. Guys, as I said, we have talked so far about the integration, the purpose, the method, the approximate method, the applications, the area between two curves. And you notice that for all of them, you have to know how to just use the integration techniques to find the integration. Then what is very crucial is the problem of the day is that how to do the integration itself. And that's the thing. Now, we are just going to today only for today review some of those concepts for some of the cool looking, I should say, integrands. Then from the next session, we are just going to build up on these ones. And as I said, it is going to be kind of a refresher of the integration method that we have talked about. Okay, in order to use the substitution, I'm just going to divide the integrands into three parts. Once we call them algebraic integration. We have talked about that a couple of sessions. We have trigonometric. And also we have logarithmic. In order to use the substitution, I'm just giving you three different classes of the integrants. Then it helps you a lot when you just want to just take the integration using the substitution. Then you take a look at the integration. Then you identify which class of the function it belongs. Either it's logarithmic, trigonometric, or algebraic. We have extensively worked on the algebraic and trigonometric, but we haven't just worked so far on the logarithmic. I'm just going to do very quickly a couple of, I should say, questions involved that logarithmic functions. When it comes to the substitution, then we just move on to just solve one trigonometric function. Now, as an example, we are just working as an example-based approach when we are gonna talking about this. We said that the first integral that we are gonna work, we say that it's going to be x to the power 3, x to the power 4, minus 1 d of x. Now, we are gonna solve this integral. First of all, what was our approach? We'll look at this. We do not recognize that based on the table of the integration, which I gave that to you. Some of the easy, good-looking integrals that you have it on the table, and you know the answer. If it was there, we learned that, okay, we just use that answers from that table, and that's we are done. If you do not see it directly there, you have to be cool, play it smart to make it to look like that. And that was our strategy so far. Now, in order to do that, we are just going to be cool and try to modify this. How to do that? I'm just going to use, because the only method that we learn for the IB is the substitution, then it seems to me I have to substitute something because I do not know any other methods to solve it at the IB. Just one substitution method. Then as a result, I say that, okay, I'm just going to get the most bad looking part of this function, which is the denominator, as a substitution to make it look a little bit better. In order to do that, we say that, okay, we say that x to the power 4 minus 1, I'm just going to substitute it or rename it to the u. Then it means that the integral which we had over there, it turns into the x to the power 3 u, we have dx. I'm just going to review that very quickly because I have talked about this many times. That's a kind of a quick review that it helps you prepare to just work on a problem per day. Then we notice that now here, look at this. What do we have here? It says that the variation is happening with respect to dx, but now we have something which is expressed in terms of the u, which they are not compatible. Now, what is the solution is that to make everything looks uniform. Everything is going to be expressed in terms of the u. How to do this? Let's start by the d of x. We say that here we have an equality, something on the left with one variable equals something on the right with another variable. Then it means that if those equations is valid, then the variation with respect to variables also should be equal. Then we take the derivative from both sides. From the left side, the derivative becomes what? Becomes 4 times x to the power 3. And I'm just going to denote it on the left that the variation happens with respect to the x. Hence, I put d of x. Then the variation on the right always happens with d of u. Now, I'm just going to bring the scissor, cut d of x from here, replace it with d of x here. In order to do so, we remember that in order to express d of x, we can write it like that. We divide both sides by 4 times x to the power 3. Then 4 x to the power 3, d of u represents d of x. Then I bring the scissor, cut the one which is here, and replace it with the d of x which I have there. Then as a result, then what do we get here? We get, now as an integral, let me rewrite it here. We have x to the power 3, which is loitering around there. We have divided by u as before. And instead of d of x, I'm going to replace it with this one, which is what? Let me change the color to make it distinct. Multiplied into 4x to the power 3 d of u. You see, oh my God, that's very interesting because everything looks very easy now. I have x to the power 3 here, and I have x to the power 3 here, and they are the same. I can cancel them out, and the final integration, it can look like that. I have d of u over u. No, just let me, that's it. And I have, remember that, guys, also we have 1 over 4. This is 1 over 4. I can just take 1 over 4 outside. Look at this. I can take 1 over 4 outside as a coefficient, which it comes outside, and now I'm left with this one inside. And if you remember from what you have on the table of the integration, anything looks like that should be what? The integration. Do you have that table with yourself? The handout which I gave you? Know what? Guys, I told you that that's going to be the Bible of integration. You should never come to a calculus class without that Bible. Coming to a calculus class without that Bible, it means that you go to a driving test without having a car. It's, yes.
I never got the Bible integration because I was dead.
Oh, okay. I'm just going to bring in the next session for you. Maybe I have it. Hold on a second. Rian, this is your day. I have one here. This is your day. You got your Bible. Guys, remember, this is very important. Coming to a calculus class without that thing, it's a little bit bad. Yes, I have some more. I'm gonna sell it for $100 each. I have some. I need who wants that? There you go.
Yeah, the online version of the Bible.
Yeah, you have a PDF.
I do have.
I don't usually carry paper.
Oh, okay.
I write all my notes.
Okay. Then I just put it on. I have some papers which they are not really that I use if you want, but this is not the staple. Then I'm just gonna put that on the Google Classroom that you have your Bible when you come to the class on your laptop. Now, in the Bible that you have, you see that in that table, there is a very interesting looking function, and that's that. It says that d of u over u, it is always ln u plus c. That's one of my favorite looking functions. ln u, d of u over u. Then if I look at this, I see that I have the same thing. I have 1 over 4 d of u. Look at this, d of u over u, which is going to be what? ln of u plus c. But the problem is that you see that we started with something with respect to the x. We got something with respect to the u. It means that somebody is talking to you in German. You're responding back in English. You have to just, make everything back to the same language. What is our own language here with respect to the x? We know that u is essentially nothing than x4 minus 1. Then I'm going to bring it back here and write it here 1 over 4 ln x to the power 4 minus 1 plus c, and we are done. You see how that Bible is going to be useful? If you do not have it, you're stuck there. du over u. Oh, you can spend days and days and days and days. Now, any questions? No? Everyone is happy? I'm going a little bit fast just in order to make sure that you are covering many problems that you want. If it got to stop, you see that at home there is a problem, check the recorded session there. Let's do this one. We have sine of x divided of cosine x plus 1. Everything is respect to the of x. And you're going to see a kind of a pattern when we are working with the logarithmic function. I hope that you all understand the pattern, that after next problem, I give you an integration and you close your eyes, you say, yeah, that's the answer. You just don't need to do the substitution. That's the purpose. Now, guys, those people who have the Bible handy, can you find this integration there on the table? Of course not. Then the problem is that you have to just, the only thing which you see on your Bible is these integrals. For example, the integral of cosine x d of x is sine x, or vice versa. Integration of sine x becomes minus cosine x. These are the things that you see. Then because you do not see it there, it means that you have to play smart, do some kind of tricks, do some manipulations to take to that one of those things that now. And after this one, you are going to understand why I do this substitution. Always in this kind of substitution, I look at the denominator. I'm just going to rename it. I'm just going to rename it as cosine x plus 1. It's going to be substituted or renamed with u. Then as a result, I can rewrite. Let me erase this one because I need the space in front of it to continue with that. Then I say that if I do this, I see the integral is summarized as sine x over u d of x. The same problem that always we encounter when we are dealing with the substitution. We have variation with respect to one variable, but we have also another variable. We have to harmonize it. And I'm gonna explain it a little bit less for this one because that's the thing which we have done. I take the derivative from the left side. It becomes derivative of cosine x plus 1. With respect to the x, it takes you to minus sine x. I'm careful to add d of x, which it's yelling at me that the left side is varying with respect to the x. When you see d of x, you see that someone is yelling at you that I'm changing with x. On the right side, someone is yelling at you that it says that I'm changing with u. That's why you write it d of u. Now, you bring your scissors. You just do what? You want to cut d of x and replace it with the d of x here, which it means that you divide both sides by minus sine x, and what do you get? D of x equals to, let me erase this part, and d of x equals to d of u over minus sine x, right? Then I just bring the scissors which I have. I'm gonna cut d of x here and replace it with the one which I already found. Becomes what? I have sine x as it was there before, u, and instead of, I should say, d of x, I have what? I have d of u over minus sine x. Interesting turn of events. Look at this. I have sine x here, and I have sine x here, all the minus sine x. which it means that I can would what? Cancel them out and rewrite it as what? This minus, it's a little bit annoying. I'm gonna take it out. Then I have minus the integral of d of u of u. Again, the same thing. You go back to the Bible that you have. You see this very popular, I call this the celebrity of the integration because they are so popular, which is always ln u plus c. And now, then as a result, this result becomes what? Becomes minus ln u plus c. However, don't forget, you have u here, but your language initially was x. Then you have to translate it. What does it mean? You write minus ln of cosine x plus 1 plus c. Although this is advisable because you know that with the logarithmic functions, the logarithm function has to be positive. Sometimes it's advisable to just put the absolute value of that function. And then you just put the absolute value of ln. The other one?
No, I mean.
Yes, let's do that also. It's advisable, but as long as this is positive, because you know that with the ln of g of x, you know that g of x has to be always positive. The fundamental definitions of the logarithm functions from level 4. There, you see that we also got to the same trend. The ln of cosine x plus 1, although with the minus before. Let's do something different. Any questions so far? Yes.
Go back, right?
Sure. Is it good now?
Yeah.
Awesome. Sorry, guys, I'm moving a little bit, I should say, too fast. Okay. The next integration. We have this one, e raised to the power x, ex plus 1 dx. Now that's the one. Probably right now, you are feeling what's going to happen. If we still we are in the region of logarithmic equation, you see that the roof, the numerator, is the derivative of the base. Then you say, oh, I do not need even to just do the substitution. Now, look at this one. By now, some of you may say, you may know the answer, but let's do the substitution once more. Then we take a little bit quick break for 1 minute and a half, then we come back to do the rest. Now, as usual, we just take the one at the denominator with a different variable and we substitute it. It means that I'm going to look at this guy and I say, I'm just going to rename it. I'm just going to say e to the power x plus 1. It can be written as u. If that's going to be the case, I'm just going to rewrite this expression. It becomes the integral of e to the power x over u d of x. The same problem. Variation is expressed in terms of the x, but we have two things that varies. One is u, one is x. Let's harmonize it. I take the derivative from both sides. The derivative of e of x plus 1 becomes how much? Jacob? What do you think? That's right. The derivative of e to the power of the x, let me write it here for those people who are still interested with the derivatives. We said that d over dx of e to the power u is u prime times eu. Then if you extend it as an example, you say that d over dx of e to the power x, it is e to the power x. And you remember, we said that this is the only function in the whole universe that its variation matches with the exact function itself. Yes, absolutely, sure. You cannot find any other function who shows that treatment. The function behavior, the function variation is the function itself. Now, then as a result, if I go back up and I take the derivative from both sides, I get e to the power x. Something is telling me that it has to show that the variation is with respect to the x, then dx equals du. Then it means that if you want to take the x from here, use your scissors to cut the one up there, then you express d of x here by dividing both sides by e to the power x. You get this one. Then let's take d of x here, replace it back up there. Then it becomes e to the power x over u times 1 over, let me change the color, 1 over e to the power x d of u. Look at this. Again, the same trends that we are interested to see. Something at the roof, something at the basement, they can cancel out. Then what you are left with is the integration of d of u over u. Again, that's the same integral that is very popular. D of u over u becomes what? Ln of absolute value of u plus c. However, don't forget that you have u here. The original language was in x. Then let's translate it back to our original language, which it means that this becomes then Ln absolute value of, I know that the u is ex plus 1 plus c. Then that becomes the result of this integration. Yes? Then as a result, guys, I hope that everyone got the pattern. The pattern is this. You have a roof as a numerator, and you have a base as a denominator. And you look at the base of an integrand. If the roof is the derivative of the base, then you do not do the substitution at all. Say it's become Ln of the denominator. Shall I change the page or I give 1 minute to this if you want to complete it, then we just write the conclusion. Then we go to the trigonometric integration. Okay, shall I change the page? Everyone's fine? Now, you know that the record is, the session is recorded, it's posted on the Google Classroom, and also these slides of the whiteboard is also on the Google Classroom. Both. Now, we are not going to solve it. We are just going to guess what's the value. The integral of, let's say, you just lean back, take a deep breath, close your eyes, the answer comes to your mind. Because that's that easy so far, based on the two examples that we solved. Anybody solved it? The pattern, yes.
Can you see the answer?
Yes.
Then it would be 1/4 log denominator.
So what? Can you please show that to me? Absolutely. But don't forget that she said the absolute value too. Awesome. Awesome. That's great. Thank you. Now, shall I do this? Do it together? Can we take a break? Yes. Almost, but there is a minor correction. You see, having the Bible is helpful.
Yeah.
You see? Now, guys, now let's do this together. Then we take a quick break. Then we come back to the second type of integration. What time the class finishes today?
240.
2:40.
Yeah, half an hour.
2:40, yes. Half an hour. Guys, before we do the substitution, we look at this. I recommend you do the substitution yourself. It's a kind of a practice. But even before you do the substitution, I'm just gonna close my eyes and look at two things. The first thing is this. We'll look at this, x to the power of 4 plus 5. That's the denominator. And I look at the numerator. I see, wait a minute, there is something very, very interesting happening there. What is that thing? It says that if I take the derivative from the denominator with respect to the x, which means that if I write d over dx of x to the power 4 plus 5, based on the things that we have learned for the power functions, it becomes 4 to the power 4 times x to the power 3, right? Now, when I look at the numerator, I see that I have the same x to the power 3. Look at this. I have x to the power 3, and I have x to the power 3, but the 4 is missing. Then it means that it makes me so close to use this identity from that table that d of u over u should be ln of absolute value of u plus c. At the numerator, you have the derivative of the denominator. That's what it tells you. Essentially, what it tells you the story that the numerator is the derivative of the denominator. But I do not have 4. We have learned that. I can just multiply this to the 4 and at the same time divide it by the 4. We have learned that in level, maybe before level 3, that we can multiply and divide at the same time. It means that nothing has happened. If I multiply this by 4, it makes it to look like that. 4 times x to the power 3 divided by x4 plus 5d of x. Now, if you look at this one, now we have 4, x cubed is essentially the derivative of the x4 plus 5. You see that the numerator now is a derivative of the denominator. However, it seems as if I give you $4,000 and I say goodbye. No, I take that $4,000 back from you. It means that what I'm going to do is that I'm going to divide it by 1 over 4. 1 over 4 times 4, it means nothing has happened. But that 4 here, it helped me to reconstruct the numerator as the version of the derivative of the denominator. Then as a result, I get what? I have 1 over 4 here, and I have the same rule that we have, ln of absolute value of x4 plus 5 plus c. And that's the answer. However, you want to do this one, you can say that I want to do this transformation, not the transformation, substitution. As an exercise, you say x4 plus 5, I'm going to rename it as u. And you continue the rest with the substitution method. You see that you get to exact same answer that we got. But this one, I was a little bit, I should say, played a little bit cool and smart because I said, I know the trend. If the numerator is a derivative of the denominator, I'm just gonna use the ln function. Now, happy everyone? No questions? No? Then we can take 2 minutes break. When we come back, we continue with some other exercises. Let me pause the recording. Recording. You said 2:40 the class finishes. 2:40. Okay. I think one more example should be fine. Guys, please quiet. Let's work this through. We have the integration of sine pi x times e to the power cosine of pi x d of x. Let's solve this. Okay, the plan which I have is that I'm just going to also walk you through this exercise. Then we are going to stop the solving the exercises together. Then I'm just giving you 2 samples that you just work it with the help of your partner, or if you just want to just work individually. Then that's going to be the last one that we're going to solve. Then if you are getting exhausted, it means that there is a light at the end of the tunnel right now. You should be happy. Now, look at this. Again, we take a look, we see that these integrals, they are not on the table that we have. But what do? We say that, wait a minute, I know the function e to the power x. It's always so fun to work with this because it's derivative. It's the same as the function itself. That's why we like that function. Then if I like that function and I do not see that e of x is there, I see instead of x, I have cosine of pi x. Then I say, okay, wait a minute. Is it possible that I do this? I say that, okay, I say cosine of pi x, which comes as the exponent of the e, I just rename it with the u. In that case, I get e to the power u, and that's my popular function. It means what? It means that then the integral is reduced to what? The sine of pi x. Now it is multiplied to the e to the power u. However, we just still are keeping d of x, which is annoying. Everything should be harmonized, expressed in terms of the u. As you know right now is that I'm just going to take the derivative from both sides. I know that as an identity, d over dx of cosine of ax is what? Minus a sine of ax, which is essentially, it comes from this huge, bigger picture that d of x of cosine of f of x, it's essentially minus d of x of f of x times the sine of f of x. I hope that you still remember these things from the things that we discovered before the Christmas, and we had so much fun on there. It was the composite functions, the story of pregnant functions, those stuff. This is the end result of those stories. This is the very end result. Then as a result, if you have cosine pi x equals to u, then if you take the derivative from both sides, it becomes minus pi times sine of pi x d of x equals d of u, right? Then as a result, you say that if I multiply both sides by minus pi sine pi x in order to isolate d of x, then I get d of x equals to 1 over minus pi sine of pi x times d of. Then as a result, the integration that we had over here, it's taken to this one. We have sine pi x, which is originally standing there. We had e to the power u, which it was the result of our direct substitution. And instead of d of x, I'm just gonna take this one, take the scissor, cut this one, and instead replace it with this, which it means that it becomes 1 over minus pi sine of pi x. And I have d of u here. You see that? Look at this. I have sine pi x. I have sine pi x. It seems that they can be canceled out. Then as a result, what are we going to end up with is that, first of all, that's right. That's correct. Thanks. Look at this. Minus pi here. It's like a constant. 1 over minus pi. Let's take it out. Let's expel this from the integration. And what do we end with? We get 1 minus 1 over pi integral of, you see that still we have e of u here, but we have d of u. Shall I erase the last line? Have you written this? I'm going to erase this. That makes some space. Now, what do we get here now? Look at this. If you go back, check in your table of integration, you see that we have this identity that the integral of EU d of u is essentially EU itself. That's why I told you coming to a calculus class without having your calculus Bible is a blasphemy. That's why you have to have it today with yourself. You see that now things are very easy. You have EU d of u and you recognize that on that table. Then you say that now the result, I'm going to keep minus 1 over pi as it was here. And I know that it's going to be what? E of u plus c. However, now you have someone here who's speaking in German because this is expressed in terms of the u. But originally someone was speaking in English, which is x. Now we have to translate this. How to translate this? I know u is gonna look like this, sine pi x. Let's translate that one to this. Then it becomes what? Equals minus 1 over pi e to the power instead of u, I'm gonna write cosine pi x plus c. Isn't that beautiful? See, the substitution makes life very easy. Makes it easy provided that you have the access to the chart of the integration. That as soon as you resubstitute and substitute, you identify something similar on that table. Ah, I love that question very much. Looks very fancy, huh? Any questions? Everyone's happy? Now, the thing that I want to do right now is that I'm just going to give you, how much time do we have? 10 minutes, huh? I'm going to give you one integration for today. You solve it. You can just work alone, just work with a partner. You prefer do some stretching, do not do anything, which I do not recommend it. Get yourself involved. Solve this one. It can become like the homework that you were going to do. Okay. let's do an homework. And I say, okay, solve this integral. Ln of x divided by 3x d of x. What is this integral? Now, we are just going to solve this. I'm just going to uncheck a little right now in order to